So welcome everybody. Today we are doing blockchain community round back session, and that's the information session where we are picking up different topics, and each session is dedicated to a certain topic. And today we are presenting our work we did for OpenVASP implementation. And during this talk, we will introduce the overall topic and we'll discuss the scope we had for our project. And then guys will speak about the development, about the challenges, about how we resolved them, what were the results. And at the end, we will speak a little bit about the future of this project. So if you are with us, I'm moving to the presentation. And yeah, by the way, today I'm presenting with our two project members, with Jan Jurazek and Alexander Belavol. And my role there was just to introduce the topic and to introduce the project to you, and they will bring you up with the technical details. So, OpenVASP. What does it stand for and what is all about? First of all, I do believe that most of you working at EPAM have ever heard about Know Your Customer, so-called KYC challenge, and about anti-money laundering and counter-terrorist funding. So basically, we are speaking about the topics where financial operations needs to be done between known parties. And most of the governments in the world and most of the financial organizations in the world would like to secure that the money which are being transferred are not used improperly, are not used to funding, I don't know, illegal sources. And those illegal sources are normally defined as terrorism, as the weapon, like uncertified weapon production, and some sort of the terrorist organizations. And well, in practice, that led to quite some of simple and well-known force measures where you have to identify yourself when you're doing a financial operations. When you're opening a bank account, when you're, well, basically, when you interact in the financial world, normally the party who facilitates the operation knows about you. And your bank knows about you. And in most cases, you need to identify yourself. Unless we are speaking, and remember, we are blockchain community, unless we are speaking about blockchain transactions. Because the well-known, I would say, criticism for cryptocurrency world, for blockchain world, is that allows a lot of anonymous transactions. And from technology point of view, we normally look into that as a benefit, as extension of our possibilities, and as an extension of the scope of the financial operations. From another point of view, we frequently hear from governments, from well-established financial organizations, that that's very difficult to protect the world from unauthorized money movements over, well, in this crypto world, how they say that. At the same time, the current situation with the banks are not also like very shiny, because there are a lot of efforts and a lot of where say money is spent to facilitate know your customer procedures and all the AML measures. First of all, to be compliant, the banks spend a lot of money. They have to validate all the information. They have to keep all the information updated. At the same time, when implemented improperly, like like the IML breach can cost bank more reputation, which also translated in money. And also, yeah, because of all the challenges to make sure that a party is known, the process is very, very slow. And therefore, customers are normally seeking for the providers who are doing that much faster. You already know that for like a lot of commercial transactions already, a lot of money movements already done in the crypto world, like, you know, a lot of Chinese markets, a lot of Chinese factories who are just converting their money into the Bitcoins and then sending that over the network because they don't need to comply doing that. They don't need today to satisfy a lot of procedures, a lot of checks, something. It's a simple way to move the money across the borders, which basically makes crypto world right now totally different from the standard financial world. And basically, there are a lot of ways how like the standard money moving and standard organization in the financial world are trying to simplify, make that cheaper and make that faster. But at the same time, there is a movement of the crypto world to basically come to the more compliant, more clear, and more transparent business operations. And there is a body operating globally, which called FATF, Financial Action Task Force. It's really a global organization who produces standards and recommendations concerning anti-money laundering, concerning all those, I would say, all those fraud operations and consulting almost all governments in the world. This is a well, it's not a big organization, but it's a powerful organization which produces standards and basically explains to governments how transactions or how the operations in the world needs to be done to make sure they're compliant and they're sustainable to all this gray world, all those terrorism attacks and something. And lately, FATF started to produce standards touching crypto world, touching cryptocurrency world. And one of those rules is FATF travel rule, where they have a special recommendation which speaks over how the transaction, how the crypto transactions needs to be done to facilitate AML CFT compliance. And based on this recommendation, there was an organization which was shaped and called OpenVASP. And that's a community where the protocol to satisfy the FATF recommendation 16 was done. And we have joined this community with our development workforce. And basically, we had a project which called OpenVASP, where we have implemented Java client, which is basically, well, I think the only Java implementation of the OpenVASP protocol. And basically this, like the whole protocol, that's the implementation of the travel rule over the FATF recommendation 16. And let's look at that a little bit closer. What is VASP? That's Virtual Asset Service Provider. What is virtual asset? Virtual assets, that's any digital representation of value. The simplest example would be any cryptocurrency, any token, any existing currency like Bitcoin, like Ethereum, like any Ethereum-based token. It can be also a tokenized physical asset. It can be any derivation, anything built on top of the cryptocurrency. So it means that any operation of the cryptocurrency. And look into what is virtual asset service provider. That's any natural legal person who is operating with virtual assets, who is providing services, providing exchange of virtual assets between the bodies. And what the simplest example here would be cryptocurrency exchange. So you understand that when we're speaking about the OpenVASP protocol, that actually touches majority, I think almost all of the cryptocurrency exchanges, almost all the organizations who facilitate the operations with the cryptocurrencies and providing the services on top of the cryptocurrencies. So the scope of the protocol and also of the solution we've developed is pretty wide. Also, if any bank would like to operate a cryptocurrency, they would also be VASP. They will also be named as a VASP. And I think with this topic, where we understand the scope, I will move the word to Jan. Jan Jurazek, who is going to bring you over the details of the protocol which we've been implementing. And yeah, then myself and Alexander will support Jan a little bit later.
Okay, hi everyone. Let me know when you can see my screen. I'll share it now. Can you see it?
Yes.
Yes.
I can see it.
Okay. Okay, thanks. So just additional 2 words from me regarding this previous slide. So those definitions, as you can see, they are quite broad, right? But I can sometimes say Bitcoin or just cryptocurrency exchange. When you hear that, I actually mean, when I say Bitcoin, I mean virtual asset. When I say cryptocurrency exchange, I mean VASP, right? Because even though the definitions are broader, those are the most typical examples. So what is this travel rule about? It's all about transfer of funds. In this case, transfer of cryptocurrencies, right? Virtual assets. And the recommendation says that because FATF is an organization that issues recommendations, right? But then each individual country will translate their recommendations into legislation. So the recommendation. So each individual country actual legislation may vary a little bit between them, right? But they should generally be quite consistent and follow the recommendation. And the recommendation says that countries should introduce legislation that will force VASPs to exchange identities of both sides of each transfer they perform on behalf of the clients that perform that transfer, right? So both originator and beneficiary has to be known by each VASP that takes part in that transaction. And to understand what that means, let's look at a comparison of how it works right now. We right now live in a world before the travel rule has been implemented, and right now, as a customer, right, of a cryptocurrency exchange, of a VASP, when you want to transfer that, virtual asset to somebody else, the exchange is not required in most cases to check where you're sending it to, and will happily execute the transfer on your behalf, right? So you can send it to somebody with a wallet that is hosted by another cryptocurrency exchange, like here on the top, or you can send it to an address that is not even associated with any exchange, which people often do for long-term storage, especially when they are afraid that the exchange may get hacked, for example, which has happened in the past multiple times, even with quite big exchanges. So this is the world we live in now. But after the travel rule is implemented by majority of the countries, now both sides of the transfer have to exchange, have to transfer personal information about their customers to each other. So you still have this blockchain part of the transaction, right? You're sending from originator to beneficiary, but apart from that, you also have this customer information transfer. And this occurs off the blockchain because, first of all, most blockchains or cryptocurrencies don't even have that kind of functionality to store this information, to transfer this information. But most of all, this is going to be personal details of the clients, right? So you don't want that to be stored anywhere on the public blockchains, because there are privacy protection laws that would be unacceptable in most jurisdictions. And of course, the clients themselves, the originator and the beneficiary would not be happy for that data to go through the public blockchain. So you have to do that with another channel off the chain, right? So they will exchange those personal details of the clients between themselves, and only after they do that, they will be allowed to go on with this part, right? So first they have to do this and make sure that both sides have the information, and apart from that, that both sides see that this transfer is okay to proceed with, because, for example, the one side of the transaction can check with their blacklist, for example, and conclude that the other side of the transaction is actually they are not allowed to do business with them, right? So only after this part is done, they can proceed with this part.
And basically the idea, Ian, just for a second, the idea is not to kill the decentralized manner of sending funds. It's just to enrich that with the controlling functionality. Nobody's trying to regulate and control that as a central body. So despite the fact that it might be tempting, like it might be tempting and something, this idea is to enrich the current decentralized public mechanism with additional information sending and on peer-to-peer or on a more private manner than a public blockchain, but keeping the decentralized nature of the network.
Yes, and it is important to point out also that this information transfer here occurs in both directions, so that both VASPs keep records of both sides of each transfer, and this is to make sure that it will be possible in the future to trace the flow of funds in case there is any investigation. So they can pass, if a regulator comes to them at some point in the future and asks them to provide that information, each VASP will be able to provide both sides, so that it will be easy for the regulator to trace what happened and what was the path of the funds. Okay, and so the travel rule only says that those that the customer information needs to be exchanged between the VASPs, right? But they don't say anything about how this is supposed to happen, right? But in reality, the industry needs some standardized way, because this may be a cryptocurrency exchange in somewhere in the United States, right? This may be another cryptocurrency exchange somewhere in Asia, right? And they need a standardized way to communicate with each other, right? And this is exactly what the OpenVASP project is trying to provide: a standardized protocol for VASPs to communicate. And they try to achieve that with the following design principles, right? So number one is they want to be compliant with the travel rule. They want to do that in a decentralized approach, which means that any two VASPs should be able to talk to each other to exchange that information without any permission from any centralized entity, and even without knowledge of any centralized entity. It should be technology agnostic, which means that there shouldn't be any limitations on what kind of assets, virtual assets, can be transferred, or what kind of virtual assets the information can be exchanged about. So it can be bitcoins, it can be ether, it can be anything, some tokens, right? There shouldn't be any limitation here. That's their principle. The exchange should support privacy, which means that it should be encrypted. Nobody else other than the two VASPs performing that transfer should be able to have access to the customer data.
It also means that all the rules of dealing with the personal data needs to be respected.
Yes.
And
And
yeah,
not
they're also looking for the broad applicability, which means that when we are speaking about the technology agnostic and saying that any virtual asset needs to be able needs to be supported, that at the same time all the technologies, like all the cloud technologies, all the implementation technologies, all the integrations, it needs to be applicable for anyone and in every situation where that might be used. And the same speaks about the extensibility, which means that it has to facilitate the extensions and has to provide enough API to be able to be part of the any integration and support any integration, support any type of information. And it has to be efficient. It don't it shouldn't kill basically the performance of the solutions. It should support basically most of the cryptocurrencies or most of cryptocurrencies. Well, they do have some limitations on the performance, but still they provide quite large use, and those are the public solutions with known performance, and basically OpenVASP shouldn't sacrifice that, shouldn't make that significantly different. And basically the organization who started the protocol development was Bitcoin Suisse, and that's the organization in Switzerland, and they started to frame the protocol, and they shaped the community around this. And currently there are quite some, about 8 parties participating in the community, as partners, which are taking some financial parts, and only 2 of them are actively developing. And those 2 are Lücke, which are developing .NET version of OpenVASP protocol, and the second organization is EPAM. And we are responsible, and we actually took responsibility to develop Java part of the protocol. And we are actively participating in a protocol discussion, and currently we are moving over to the future. And 2 people from EPAM are part of the OpenVASP standard committee. So we are taking some part in the decision making, and we are normally recognized by the whole community as a party who looks after enterprise clients and enterprise usages of this protocol in the future. And that's how we are developing all of this.
Okay, so let me continue to the next slide. So a couple of words about the protocol, how it works, and how our Java client works, right? So this is a diagram that shows how the proposed OpenVASP architecture fits into existing platforms that VASPs around the world may use. So on top here you have an existing platform that a VASP may have, right? So this is something we don't know, right? But we will have to communicate with once the VASP solution is integrated into an existing system that any VASP may have. And it of course may be different for any VASP, right? But that doesn't matter, because they will specify that they will communicate with it with a specified in a specified way here through this interface. And on the bottom is actually the components that the OpenVASP project is going to provide. And on the right is the network that will be used to transmit messages to and from other VASPs, right? So currently this network is based on Ethereum. So even though the OpenVASP as a solution is technology agnostic in terms of what assets you may transfer, right? They use Ethereum as the underlying transport technology to exchange the messages between these different VASPs, right? But that doesn't mean that they are limited to Ethereum, to transferring of Ether as a currency, right? They support transfer of any virtual assets. Doesn't matter whether it's Ethereum or Bitcoin or whatever else you may have. And our development activities so far as EPAM, we have been focused only on this client component here, which is a Java library that handles interaction with the Ethereum network that is related to sending and receiving the messages that contain the client's personal details. And there are plans for EPAM to work on these other components in the future. But for now, we've been focusing here, and this presentation is about the client here. So another thing that OpenVASP project proposes is VASP identities. So let me explain. They are based on Ethereum. They are stored on Ethereum blockchain as smart contracts. If somebody is not familiar with smart contracts, so let me explain quickly. This is a concept introduced by the Ethereum project, and this is the big feature that was added, the big new thing that Ethereum project added on top of what was already in Bitcoin. So Bitcoin was about transferring currency between different addresses of the Bitcoin network. But Ethereum, apart from having that functionality, also has functionality called smart contracts, which basically are also addresses in the Ethereum network, but they are not controlled by individuals or customers like the regular addresses, but they are only controlled by code, right? So the typical application of that is to create to let code decide how to distribute funds. For example, you may create a smart contract on Ethereum network. You may fund it with some currency, right? And from that point on, only the code that is included, that is deployed with that smart contract, is going to decide what will happen with those funds. And nobody, not even the person who deployed that smart contract, can change how that code will behave, right? So that code is immutable. Once it's deployed to the Ethereum network, it's going to execute, and the Ethereum network itself guarantees that it will be executed the same way, no matter what, right? So there is a consensus of the whole network on the validity of execution of that code, which means that if that smart contract is well written, doesn't have any bugs, right, you can be absolutely 100% sure that the logic contained in that smart contract is going to be executed. So this is the general concept, right? But in case of OpenVASP project, actually the contracts are quite simple. They don't manage any money. They don't manage any currency. What they have is they store information about a VASP, right? So each and every VASP will deploy its own smart contract, which will be from now on will be used as the identity of that VASP. And the information contained in that smart contract are stuff like name of that VASP, right? So the name of the cryptocurrency exchange, for example, their addresses, their physical postal address, their email address, their website, and so on. Also, it will contain public keys, so that other VASPs that want to communicate with those with a given VASP can use those public keys to encrypt their messages. And it also contains a list of trusted peers, which means other VASPs that this given VASP trusts. So you can access those identities, right, which are, as I said, just our addresses on the Ethereum blockchain via their full Ethereum address, which is 160 bits long, like here. But this is very, very long and very not easy to remember, not easy to use. So they also allow to only take the last 32 bits and register them in a service called Ethereum name service, which is very, very similar to the domain name service on the general internet, right? So it works the same way. You have some short, easy to remember name like Amazon.com, which the domain name service translates into an IP address. So the same way here, you have this short, let's say easy to remember 32-bit identifier, and the Ethereum name service will convert it into the full VASP identity, right? So you don't have to remember the whole address, right? And those last 32 bits are used throughout the OpenVASP standard as the shortened version, right, of the identity, and they call it VASP code. Another thing that they propose in the OpenVASP standard is the virtual asset account number, VAN, which is something similar to the traditional banking. There is also something called IBAN. You're probably familiar. So it's a standardized account number, and they propose that all VASPs around the world use it, so that there is one single standard for account numbers, and it basically consists of VASP code, right, which identifies which VASP hosts a specific account, and then the customer specific part, which identifies an individual user with that VASP. And they also add something that is also in the IBAN standard, which is a checksum that basically is there for avoiding mistakes, right? So if somebody makes a mistake in the VAN, right? So let's say somebody writes it down on a piece of paper. If they make a mistake, this checksum will likely catch it, and it will not be accepted. You have the same with IBAN with the first two numbers of the account number. Okay, and now the messaging layer. So how the VASPs actually exchange messages between them. So they use a protocol called Whisper. Whisper is part of the Ethereum ecosystem. It's independent of the Ethereum blockchain, but every so any Ethereum node that doesn't even have to be synchronized with the Ethereum network can use it, because it doesn't depend on the blockchain. It's totally in parallel. But every single node can have it turned on and can exchange messages with this protocol. And how this protocol works? So it is encrypted, obviously, right? So every message is supposed to be readable only by their intended recipient, and it uses a very fancy way of delivery, right? So it doesn't work like usual internet routing, which let's say we have one node here and another node here, and they want to exchange messages. So normally on the internet there is a route that is calculated, and it goes something like that, right? But here actually every single node spreads every message to every other neighboring node, right? So like in this example, a message from VASP A goes through all the nodes store that message and forward it to their neighbors, and at some point the actual intended recipient will get it, right? But yeah, so it's a very inefficient method of delivering the messages, but there is a reason for that, and the reason is a property called darkness. The point here is that it not only should be impossible to decrypt the message, right, which is guaranteed by encryption, but it should also be impossible for anyone listening to the traffic that's going on that network to figure out who sent message to whom, right? Because since everybody forwards it to their neighboring node, it's impossible to tell who was the actual intended recipient. Even here in this example, you see that even VASP B, which is the intended recipient, when they receive that message, they still forward it to others because that's what the protocol says, right? So nobody can tell what two parties on that network actually talk to each other. But of course, this comes as, at a cost, and that cost is very, very high redundant traffic, right? Because instead of just going through one path, you overload the network with a lot of additional traffic. But there are ways. So when you look at it, you may think that this network may be easy to compromise with denial of service attack, right? But there are some mechanisms introduced into that protocol that don't allow you to do it, and they are based on the proof of work concept. So each node that actually wants to send a message to the Whisper protocol, depending on the size of that message and the time it wants that message to be alive, there's a parameter called time to live, which may span from seconds to even days, right? And it basically says that whichever node gets that message, it should be storing it for that time to live, and only delete it after that time to live expires. So depending on the time to live, which is set by the sender of the message, and the size of the message, there will be different requirement on the proof of work, which means that the sender will have to spend their CPU, their processor power, to calculate let's call it a puzzle, right? That is very, very difficult to calculate, but is very easy to verify. So the other nodes will only forward that store and forward that message if the puzzle is calculated in a correct way, which means that anyone who would like to perform a denial of service attack on that network would have to have a huge processing resources in order to do that, which grows proportionally with the size of the message and the time to live that message has. So in general, the network is immune to denial of service attacks. And also there is one additional thing in every message, which is called topic. This is basically a 4-byte number that is recommended to be random, right? And this is for all the nodes to. So if one node wants to communicate with another node, they should exchange the topic so that they know the topic is not encrypted, right? The topic is in the header of the message, so that all the other nodes who didn't subscribe to that specific topic would not even waste their resources on trying to decrypt it. They wouldn't be able to decrypt it in the first place, right? But even trying to decrypt it would waste their resources. So topics are a way to avoid that waste of resources. Okay, and so this is the mechanism of how messages are delivered between point A and point B. Now, what actual messages do we exchange between point A and point B? So every exchange is done within a session, and every session starts with a message called session request. So the originator VASP, so the VASP from the customer that wants to send the funds, would talk to the beneficiary VASP, and they would establish a session. So the session request uses the VASP code of the beneficiary VASP as the topic, right? So the beneficiary VASP knows that this is a message intended for them, and also it uses the public key that is stored on the smart contract of that beneficiary VASP to encrypt that message, right? So this message has a topic equal to the VASP code, but inside of that message there is a random number created by the originator VASP that will be used as a topic for every further message. And also there will be another randomly generated key for encryption of every further message. So even if somebody is monitoring this traffic, they will not be able to tell that those subsequent messages are part of the same exchange, because only this first message has VASP code, which is predictable, but all the other have random topics, which were created randomly by the originator VASP. So so the session is initiated by the exchange of just two messages: session request and session reply, and then there is a transfer phase which has subsequent messages that I will cover in the next slide that may be different depending on the scenario, right? So yeah, so the initiation phase is the originator wants to send funds to the beneficiary, right? So first they need to know, the originator needs to know what's the account number of the beneficiary. So the beneficiary needs to obtain that account number from their VASP. They will get it and provide it to the originator. The colors maybe are not that visible, but this is not part of the protocol, right? So this is the communication between people, basically, right? So the beneficiary gives the account number to the originator, and once the originator has that account number, they will request their VASP to go on with the transfer, right? So the originator VASP will open the session, which means they will send the session request, and the beneficiary will reply with the session reply. And then we will have two options, right? So there's option A and option B. A is when there is an approval required before the blockchain transaction occurs. And this is the most typical case. And why is that? So this is to avoid situations when somebody sends funds to somebody else, and that beneficiary of that transfer does not have a chance to reject it. So there may be so that's first possible scenario, right? The beneficiary may not want to receive those funds, and the second one is that the transfer may be blocked due to some compliance reasons. For example, one of the sides of the transaction is on the blacklist, right? So then the VASP would actually want to block it. The VASP would, if let's say the originator is unknown and they're or maybe he is known, but he is on a blacklist, right? So then the beneficiary VASP would reject that because they would not want to receive funds from somebody who is blacklisted, right? So that option starts with transfer request, which is basically a the originator VASP is asking the beneficiary VASP if they would allow to continue with the transfer, right? And if it is approved, then we have option. We have subsequent message is transfer dispatch, which actually let's say indicates that the transfer will occur that the originator VASP will continue with the transfer. And if that transfer is successful, then the beneficiary VASP will let know to the originator VASP that they received the funds over the blockchain. So,
Jan?
yeah.
Sorry, this is Thomas. I have a question. I'm a business analyst, so I'm a bit atypical in this session, but it's still very interesting for me. I have a question regarding that blacklist, because did I understand you correctly? This blacklist is about the actual call it the end users, or is this blacklist about the VASPs?
End users.
Because what if a VASP is blacklisted? Because that's actually a major issue right now. Say some VASPs are actually should be on the blacklist.
Yeah. So if they are on the blacklist, then they probably will not even establish the session because they will not be trusted by the originator VASP, right? So let's say we want to.
I can interfere because this topic is heavily now discussed about whitelisting and blacklisting VASPs. We do have currently like the topic where like I would say the modification of the protocol, because currently it doesn't say much about this. That basically assumes that when it's a blacklisted VASP, the connection wouldn't be established in the very beginning. But we are currently discussing as a committee how to maintain both whitelisted and blacklisted VASPs and how to do the VASP management.
Yeah, because that's why I'm asking, because about 15-20 minutes ago, there was a mention made of the VASP being in a smart contract. Well, smart contracts, that's all, of course very nice, but smart contracts you can't amend.
Yes, that's true. But currently, like if you can trust or not is not who is blacklisted and who is whitelisted is not a part of the travel rule. Yeah.
No, of course no. So if it's not part of this presentation, then it's all fine. But then I was just a little bit confused.
Be in half a year. We are like heavily preparing for that. We are discussing that on a host level, but currently we are presenting of what we had already developed, and that's about a client. So yeah, it's a very relevant and very valid topic. But I was just saying that the discussion how to resolve that on a best way is taking time of the community right now.
Yeah. Then I'll stop asking those questions. There's no overall kind of coordination mechanism in this kind of network, or is there? That is there coordination to actually stop processing requests from certain VASPs, or is it just not possible?
So regarding your question about the immutability of the contract, so the contract is immutable in the sense that the code cannot be changed once it is deployed, right? But the code itself may have the functionality to do whatever it wants, to do whatever the coder wanted, right? And actually they do have a method to manipulate the list of trusted VASPs.
Oh, okay. Yeah. So you actually, from a coordination point of view, so network coordination point of view, you can actually just a blacklist and say, okay.
You can the administrator who deployed that contract, right, can call this method, right, and add a VASP, giving their address here, and they may also remove it, right, when they, for example, that VASP is no longer considered safe. All right, so you can also remove the trusted peer from the list.
But that function is currently there, or not yet?
Yeah, it is.
It's there. You can see the code. Yes.
Yeah. And who
the idea is to how to make a decision and how to exchange this information over the network. That's what is going to be designed. But the functionality on a client level is already here and implemented.
Yeah. Okay. No, that answers my question. Yeah. Thanks.
Okay. Yeah. So yeah, I think that's everything I had to say about the slide. So basically, the point here is that you can start from point B without. So in some cases, you may not even need to ask whether you can continue with this transfer. For example, when the transfer is from an account of an originator to a beneficiary, and this is a transfer that occurs on a regular basis, right? So likely, the first time, second time it occurred, right? This request and reply was done, but then there's no point in doing it every time, right? The both VASPs and originator and beneficiary may decide that they just want to perform that transfer on a regular basis. Then there is no point to perform those two first steps, right? In those cases, they can start from point B, right? Which is they can proceed directly to performing the transfer and not asking whether this transfer can be performed, right? So this OpenVASP protocol gives VASPs the flexibility to omit this first, let's say, asking for permission step, right? Okay, and now the implementation details. That is going to be explained by
Alexander. Yes, Alexander, can you hear us?
Yes.
Will you take over the control and do the presentation? Yeah.
Yes. Excuse me. Let me share my screen. No, it's not. Desktop.
Yes, we can see your screen. We can see the presentation, and that's the right slide. Yes.
Okay, very good. So about implementation details. First of all, I'd like to say that the project is open source, and you can download whole code base of the project from GitHub, and here on slide you can see the address, but if you don't remember, you can easily Google OpenVASP project GitHub, and you will see the address. In the GitHub repository, there are two projects, C# implementation and Java implementation, which was done by our team. So, because we don't have enough time, I want to stop only most interesting points of implementation. So, the first one, let me describe the layered architecture of our client solution. So at the top level, we have central gateway object, and we should do all operation via VASP client object. It based on the next level of session management, because OpenVASP protocol is session based. So in our implementation, we also have quite simple session management, but nevertheless we have it. Session management is based on service layer, which provide basic services of sending messages, doing some cryptography, working with JSON serialization, working with smart contracts, and so on. And service layer based on low-level modules, which include models for every type of message described in OpenVASP white papers and JSON serialization according the field names described in white papers. Also, we have module to communicate with Ethereum node by Whisper protocol. We have a separate module to work with contracts, and we have crypto API module to work with keys, asymmetric and symmetric keys. Short facts about implementation. We use for dependency injection. Actually, we use dependency injection to link each component. And for dependency injection, we use Google Juice. For JSON serialization, we use quite standard solution, Jackson. And to communicate with Ethereum network, we use web implementation, we use Web3j. It is standard implementation of Ethereum client library, and it allows us to work with Whisper nodes. Also, it allows us to work with smart contracts. And Web3j contains as a part bouncy Castle crypto library. It is quite famous library, and there are implementation for Java and for .NET. The next slide. Our solution supports two styles of work with messaging, sync and async APIs. Each of them may be suitable for different situations. Let's go through differences. So, synchronous blocking API allow to send VASP messages and then either wait for response or periodically poll for new messages. The flow is totally controlled by a host application. And the asynchronous callback API allow to register a callback to process each type of VASP messages, but the flow is controlled by library, and the library invoke those callbacks to process messages and get the response of each message. The next difference, because, for example, if message processing involves some kind of user interface, each step of message processing may include some UI interactions to show new messages to the end user and wait for his or her decision about the next step of processing. And asynchronous API, the purpose is to allow some kind of automatic processing when we have some predefined rules that doesn't require any human interference in processing of messages. What kind of what style of API should be used? It depends of the goals of host application. Actually, we can mix each approach in the one host application. Okay. The next slide about session management. As I mentioned, our solution includes simple session management. We have two types of sessions, originator session and beneficiary session, and the details of session management depends of the mode of our client, async or sync mode. But the limitation of the session management we have implemented is that the session data is kept in memory. But if a host application need to something more complex, more complicated, our library provide via VASP object provide access to service layer, and via service layer you can access to functionality of sending and listening for messages, and different strategy of session management can be easily implemented via our client library. Okay, a couple of words about how we work with smart contracts in Java. There is a very useful Maven plugin to work with smart contracts, and it allows to generate Java wrapper class to interact with smart contracts method and properties. So actually, smart contracts are written in a special language, Solidity, as far as I remember. And when we compile those Solidity contract source files, we can get ABI file, application binary interface file. And Web3j Maven plugin takes those files and generate equal Java wrapper class. And using those class, we can easily interact with smart contracts deployed into Ethereum framework network. And in current implementation, generation of Java wrapper class is included into the build process. And the last slide about integration testing. The OpenVASP client organized in the way that two different endpoints can be configured to interact with Whisper API node and Contract API node. It allows us to use, for example, private Ethereum network to check message exchange by Whisper protocol, but for testing contracts API, we use pre-deployed contracts Actually, the team of C# implementation already deployed all necessary contract into Ropsten network, and it is quite easy to configure our integration test to access those pre-deployed contracts via Infura and Gateway. So if you are going to build our client and run integration tests, you need to configure two endpoints for Whisper API node and Contract API node. Actually, that's all from my side about technical details. So, Alexandra, could you please proceed?
I think I'm already here. Guys, can you see my screen now?
Yes.
Okay, so, oh, Jesus. Let me quickly scroll because I switched the presentation mode. And basically, you've seen the work we did so far of implementing the client. And I think that will like the red circle on this picture. And we are currently, okay, since the beginning of this week, we are already in the mode where we are developing the host and associated user interface for the host management. So we are continuing and we are enriching our Java implementation on OpenVASP protocol, basically to ensure well, all the components of the protocol and all the functionality can be consumed in Java. At the same time, the protocol is moving forward. Within the last month, while we were developing the client, while we were testing the client, the OpenVASP community have shifted from like typically, open source Telegram communication towards the community website. And here you can see the link to the website, and you can see what is open community, so everybody can join and everybody can just open and read. And you can see the ongoing discussions we're having and we are participating. And what the key point of all the discussions are the next steps and also verification of the protocol, if it's enough or not to go live and to be implemented in practice. Well, strictly speaking, according to FATF, all VASPs should strictly recommended to implement the travel rule according to FATF guidance by the June 2020, which means in 2 weeks. Also, FATF is a recommending organization, which means that every government still needs to accept that and still need to detail and to ensure to which, to what level it would be implemented by the particular country. But still, you can see that FATF is heavily pushing of that being implemented at the places. And therefore, the community working on a protocol is checking. And first of all, we've developed the mechanism of how the change requests needs to be incorporated in the current version of the protocol or the current version of the implementation. And the change request in our world called OVIP. And currently there are 5. You can see 4 in a picture, but yesterday we've actually accepted the 5th one. And first of all, we do expect already changes to the current VAN number processing. It will still stay the same length, but the components of like 24 digits will a little bit change. We will have leading 2 digits of the type of the VAN number, which will help us to diversify the processing of the certain numbers. And it will also have somewhere in the middle 2 extra digits, which are dedicated for the future purposes. Then, according to the Thomas question, you can see OVIP 3, which speaks about WASP identity and managing WASP identity. And that's quite interesting in big OVIP, where we're discussing how the WASP information should be shared like on a decentralized manner over the network, and how to know which WASPs are trusted WASPs, on which ones are blacklisted. Also, OVIPs 4 and 5 are speaking about the processing of the transaction, about the reliability of the Whisper solution, about the guaranteed message delivery. So the really nice and practical extensions of the protocol. And as we can see, this standardization and protocol work, it will continue in the future. And we now have the quite good mechanism of incorporating new things or working on existing imperfections and voting on that. And that's a pure community work. There are two people in EPAM, that's myself and Jorge from the payments group, who are participating as a part of the standard committee and basically reviewing those OVIPs and expressing our opinions and also participating in voting. We do have a weekly meetings on that. And yeah, as I already mentioned, we have ongoing project, which is developing the host application and associated graphical user interface to manage host, which means that somewhere in a month or two, we would be able to share with you guys what the news of the protocol and how does it work on a host model. And I think with this word, we are concluding our presentation today. So probably the one more word I would like to mention is we would like to share the thank to EPAM open source community. We do have organization within EPAM who helps with the open source development, who provides some guidances and best practices. And they helped us in the beginning and they continuously helping us. And basically, as both Alexander and Jan already said, you are very welcome to go to the GitHub to look at our code and to use that in the future if it's necessary. All three of us are here to answer your questions if you have any.
Thomas here. Can you hear me?
Yes,
Yes.
we are listening.
Always one of the nicer parts of a presentation like this is seeing it work. Is that possible? Can we? Could we do it? Do they have a sandbox environment available? Can we see it work? Can we see the work we did work?
We do have the integration testing environment. There are the Robston contracts. So you basically, or I guess with the help of developers like Jan or something, you can install things locally and you can communicate. Yeah.
Yeah, I understand, but that requires quite some setup. I think for maybe many of us. But could Jan and Alex, could you show it in a kind of demo-like fashion how the code works?
So you got us. So it works, right?
Yeah,
what we can show right now is basically an integration test, which is, yeah, we would run 3 different Ethereum nodes, right?
Yeah.
Run test through Maven, and you would see just lines that tell you test passed, right? Not sure if this is so because since we don't have those components that
we don't have host and the GUI, so
exactly.
you can see the session. I mean, in 2 months, like what? We have a month of the development and somewhere close to the middle of the June or second half of June, because we will need some time for the preparation, you should be able to see that in a user-friendly manner. For now, we can run the tests for you, but you will see that those passed and you can basically sniff on a Robston network to see that actually it's flew by. But to see like where there was a session, when the session established, connection established. For that, you need an interface to visualize that for you. And
Yeah,
that's
but
the scope of our current project.
okay, no, but it's not. I'm not necessarily interested in the visual aspects only, but just show us the transfer of the value. Just do kind of an imaginary transfer of ether.
So this is not even done, right? Because the Java client, it is only concerned with sending the messages through Whisper, right?
Yeah.
And
Yeah.
through Whisper, you only send those those pieces of information about the customers, right? Their personal details, stuff like that.
Oh, okay.
But
Yeah.
but the blockchain transaction, right, of actual Ether or Bitcoin
There
or
would be
some
ether transactions. Yeah.
yeah, I mean, yeah, but still, it can be anyway, right?
Yeah.
The OpenVASP is agnostic when it comes to what currencies or tokens it can transfer, right? But it's not done by the OpenVASP, any of the OpenVASP components. Sasha, if you could go 2 slides back to 28, right?
Yes, I'm in the process of finding this one.
Yes.
Yep.
So the on the right, lower right, you see the blockchain part, right?
Yes.
This is the part that is concerned with sending the information about clients. It's not concerned with sending the virtual assets. The part that is about sending the virtual assets is on the top part of the picture, right? But this is VASP dependent, right? Every VASP in the world may have different software, different components that actually handle the transfer of the token, the assets, right?
Yeah.
We are doing the fancy part, which covers like what basically the best explanation here was the Jan slide here.
Yeah, exactly.
On
The KYC.
like this one, well, the lower one, where it's a virtual asset transfers by itself. What we are implementing, that's a customer information transfer on top of that.
Yeah. Okay. I understand. I was distracted by all of the interesting details. So it's we do the KYC. Yeah.
Yes, we do the KYC. Yes, exactly. That's why we were starting with explanation what the KYC is.
No, but okay, but still, for that to be shown, we need there's more time required to do the setup, or is it?
I think I could be able to run the integration test right now, but just warning you that it's not going to be very.
But it's not very
exciting.
attractive. You will see the numbers.
No, that's okay. But I don't want to. Maybe other colleagues have other more interesting questions. So, but that's.
If Jan can do that, that would be nice because we will record that, and the people will see this. Yeah.
I can do that in the meantime, and you can. Anyone can ask any other questions in the meantime. Yes.
Okay. Can I ask a question, Peter Verhaas?
Yes, certainly.
Can you hear me?
Yes, we can hear you.
Okay. So my question is that if you go back to the slide that you were showing before, there is an asset provider. And could you go back, please?
Which one?
It's a very basic introductory.
This one?
Yes, that one. Yeah. There is a virtual asset service provider, and there are actually two different communication between the two virtual asset service providers. One is the KYC, and the other one is the actual transfer. And what I see here is that there are two different things and two different knowledges. One is that that somebody is transferring how much, what asset to whom, and the other one is the KYC information, whether a transaction independently of the amount probably is executable or not. And my question is that here we have two roles. Why do we have in this model have these two roles executed by the same entity? So the virtual asset service provider does two different things. One is deciding on KYC, whether the transfer can be or can't be done. And the other one is doing the transfer itself. Why don't we have a separate entity for the separate roles?
because the purpose of the travel rule is not deciding whether this transfer can be done or not, but rather to make all VASPs record those transactions. And the point is that in the future, if there is any suspicion about some transfer, right? Because the VASP may not know in advance whether that transfer should be allowed or not, and they may assume in good faith that this transfer is totally okay, because nobody is on the blacklist, for example. So, but the point is that the travel rule will force them to record that information about the other side of the transaction. So if you are the originator VASP, you will record the personal details of the beneficiary. If you are the beneficiary VASP, you will record the personal information about the originator and store them, right? And in the future, when some regulator requests that data from you, because they, for example, they started an investigation and they found out that some money was actually transferred this way, and they want to investigate the whole chain, right? To trace it to the very beginning. Each VASP will then be asked to provide the recorded information, and because each VASP has both sides, then the regulators or the investigators will be able to, go one by one and see and trace the whole chain.
It's not only controlling, but also auditing, recording mechanism. So it's not only control, it's more record keeping.
Yes, and still there are two different things which are stored together, which do not need to be stored together. So the transaction itself and the identity.
Well, the idea is to tie them together.
Data, yes, but it's, the whole blockchain is to decentralize and make anonymity as much possible as it can be. And this architecture makes it more easy for an authority to gather information, maybe forcefully, like a dictatorship, than it's needed. Because if you separate a KYC entity and the virtual asset service provider entity, and they do store the things separately, and maybe a virtual asset service provider can communicate and use the services of KYC providers, of many KYC providers, then the client, the beneficiary, the originator and the beneficiary may decide that I want to use this virtual service provider, but I want to use a different KYC provider. And they both store data, but this data, who is doing what transaction, are not stored together. The transaction, it has an ID, is stored by the virtual asset service provider, and the KYC provider stores that this transaction ID, details not known at the KYC, belongs to this originator or to this beneficiary. And then the data is separated, and the need to know is separated, the two different roles there and two different entities. Now we have two different roles and one entity.
But if it was done the way you just described, would the regulator or the investigator, somebody from the government who wants to trace how those funds were transferred, would they be able to get that information? Because that's the whole.
Of course.
Well, that would be just different network.
They need to get the data compiled together from two different entities.
But
basically, what I would say here, that it's the extension of the use case. What we are speaking here, that's just a travel rule implementation that can be set up in the future in a setup you are mentioning right now. Because basically, as you
maybe yes.
Yeah, when
maybe
you see like on an architecture, there is still a way to make this, well, you see now two errors and like here and HTTP here between like custom interface and well, basically you can multiply that. And that means that you can actually interact with different like so-called KYC providers. But basically what you're speaking about is a different use case. It's more, like it's a higher level, that's more extensive. And when you're asking us why we are not doing so, it's a strange question, because where we are doing the part, like, well, we're a service company and we are doing the part which we are being paid for. And I do see that in the future, the movement which you are mentioning may happen. Currently, the clients are interested in something different. And I believe that's because the paradigm shift is happening like slowly. Basically, they're moving to the centralized world, or the centralized way of the processing. That's the difficult and quite huge paradigm shift. So the companies who are participating, they still were in a transition mode, and I would say the standard financial service companies. Wherefore, when we are looking to like cryptocurrency exchanges who operate now without travel rule, they also they are not seeking for that. That's the government which trying to propagate and enforce the travel rule. So they're enforcing what they can imagine. And I do understand what you're speaking about, but it will take some time for all the legislation organizations to realize that and to move there. They cannot jump that far. So they will do like baby steps. And probably, again, we're not speaking like, now we're speaking about the technical possibility, right? Not about adoption, not about how it's going to be enforced or how it's going to be implemented in a particular financial organization. Although we do have a battle card explaining for the standard financial organizations what does it mean for them and what they can do with that. But it's still, baby steps. And I do see how this approach would happen, like where the government is strictly saying you have to, and otherwise you would be closed. And then they implement this. And then they started to basically, in a giving framework, in a giving borders, they're trying to disintermediate, where they started to have more providers and making broader. This is easy, understandable, than to move, like to do the big band and to move with all those like peer-to-peer or entity-to-entity information moving. I would actually say that's already it's already quite a big step, because the information is moved over like the VASP protocol, which is like the gossip wires. It's totally black. It's already a lot of change. But what you're speaking, where we separating KYC from value transfer, that's the bigger change, which will come, I do expect, later. Yeah. Hope I answered the question, because I cannot answer that because we are just witnessing what is happening in the world, but I probably can, that's probably the explanation for this.
I absolutely like your answer. I understand what you're saying. I see that the blockchain and all these currency things, we're going from normal money transfer to anonymity, and then the swing is going back. So that the government says, okay, I cannot prevent it, so I need to control it. And then they try, and now we are part of it as service providers implementing the technical part. They try to have as much control as possible, of course, because that's their need. But we technically should see that probably this is a little bit too much, and that it's not really what they really need to have for legal.
Well, the market will answer. I'm pretty sure that the market will answer, and we will see all the alternative movements. It's like, again, that's you can see that's it's a standard, like what the OpenVASP is aiming to be the standard de facto. It's definitely not de jure. So it's not pushed as like this. The only travel rule, which is a recommendation, and then the OpenVASP is just one of the implementations. Well, it's probably the most advanced one for now, but I would see that when the travel rule would be actually enforced by the certain governments, we will see what market will answer, and we will see how the cryptocurrency, the cryptocurrency world, the crypto community will move. And yeah, there are alternative projects, there are alternative ways, and even more like more dark, more anonymous. And yeah, that's a typical market move. Yeah.
Mm-hmm. Thank you very much.
Yeah, and just add one more thing. I agree that this is not something that the Bitcoin community will like, and even there are some predictions because nobody knows how exactly it will play out and what the specific country regulations will look like. But some even predict that you will end up with, you know, divergence in Bitcoin prices between different, let's say, jurisdictions. And you will have, let's call them dirty Bitcoins, right? Which some exchanges will not accept because they would not be compliant to the travel rule. So there may be unintended consequences.
Guys, more questions over the implementation? Seems, Alexander, your part was the most clear one because the session was planned for developers and we don't have any development questions. Seems, Alexander, you cover all the possible questions, which is, yeah, remarkable. Guys, if we don't have more questions, we will close the session. First of all, we would like to thank Alexander and Jan for bringing us this information and actually for participating in this open source project. And a second, I would like to announce that next week, the same time, we will have another brown bag session where the blockchain community is going to speak about the cryptocurrency wallets. So if you are interested in a topic, stay with us, join us in our brown bag sessions. Also, if you are curious, you read about blockchain, you are participating in a blockchain investigation or in our blockchain community, and you are interested in a certain topics to be brought in our brown bag sessions, mail it to me, and sooner or later we will actually develop the community mechanism to basically to reach out to you and to keep the history of the topics and the demand for new topics to be spoken. But for now, if you are interested in this particular subject, just let me know and we will see if we can facilitate this knowledge transfer, like information transfer. Yeah. Thank you. Thank you for being with us. Enjoy the day.
Thank you very much. Bye-bye.